In defense manufacturing, precision isn't optional. It's essential. Yet complexity continues to grow. And most scheduling tools simply weren't built for it. Until now. This is Opcenter APS for defense. Built to handle complexity, deliver reliability, and drive competitive advantage. Let's dive in. Think about what defense manufacturers are dealing with today. Demand is up, deadlines are tighter, products are more complex. And the result? Most teams are stuck in firefighting mode. They're chasing problems instead of preventing them. Here's the truth. You can't stay competitive that way. So what do you actually need to compete? Visibility. You need to see your entire operation in real time. Your capacity, your constraints, your bottlenecks. Proactivity. You need to plan ahead, anticipate problems, and stay one step ahead of complexity. And control. You need to optimize your resources, meet your schedules, and execute your plans consistently. This is what you will achieve with Opcenter APS. Let's see it in action with a demonstration. Here's the Opcenter APS main menu. Your complete planning and capacity management platform. Let's first explore the configuration and data setup before we move to scheduling and optimization. We start in the products table. Here's your product catalog with all the routings, showing every operation for each product. Next, we move to the product's bill of materials table. Here you'll find the complete bill of materials for each product. We then move to the work orders table. This contains all the orders to be scheduled. Each work order inherits its routings from the products table, but is characterized by a quantity, a due date, and attributes such as civil or military, and whether it's a customer order or MRO. We also have the bills of materials table. This contains the bills of materials linked to each work order, based on the product's bill of materials we saw earlier. This table gives us visibility into all the component requirements for the entire schedule we need to plan. Now that we've covered the fundamentals of routings, bills of materials, and orders, let's see how these concepts come together and are put into practice in the scheduler. When we open the sequencer, we're presented with the work orders view, the Gantt chart showing all our machines, a list of unscheduled operations, and a color legend to guide us. Now let's start by applying the bills of materials. We'll use the PEG materials tool, which creates connections between our component producers, whether that's stocks, supplies, or semi-finished orders, and the consumers, which are our work orders or customer demands. Once these links are established, we can turn to the Material Explorer to visualize all material availability and relationships. In the Material Explorer, the work order sits at the center. The produced article appears on the right, and on the left, we see the components from our bill of materials, along with their linked items. In this case, the component is supplied by an order. By clicking on a supplying order, we can drill into its details. We can repeat this as many times as we need to trace through the entire supply network. If you prefer a broader view, the navigation pane on the right gives you direct access to the complete list of planned shortages. Double-clicking on any shortage in that list takes you straight to the details of the affected items. You can also use the material control after scheduling to get more detailed information on the production and consumption dates of your materials. Look at this example. The components are required at the order start, and the product is produced at the order end. You can navigate through the data and see all production and consumption dates across your supply chain. Here's what makes this powerful. All these dates are based on your scheduling results, calculated using our multi-constraint algorithms. This means you can use this data to fine-tune your purchase plan and avoid overstocking materials. Now that we have the foundational information in place, we can run our first scheduling. To do this, we'll use a simple rule called forward by due date, which sorts our work orders by their due dates and schedules them from most urgent to least urgent. Once Opcenter APS has created the schedule, we can highlight the entire network of linked operations, along with all the supplies and demands connected to them. No matter how complex the network becomes, Opcenter APS automatically respects all precedence links. and ensures that operations are scheduled in the correct sequence. This guarantees that no operation will wait unnecessarily for a component further down the line. Now let's look at how these scheduling principles apply to real defense industry scenarios. We'll walk through 4 practical use cases and show you how to set them up directly in Opcenter APS. First, managing limited skilled resources. In defense manufacturing, certain operations require trained operators. The question is, how do we schedule these operations when we don't have enough skilled personnel available? The answer starts in the machine table. We add a secondary resource to our assembly machines. Secondary resources can represent skills, tools, or any constraint that limits how many operations can run in parallel. Here, we specify that each assembly operation requires 1 operator with assembly skills. Now, Opcenter APS takes all this resource information we've just defined and uses it to build a realistic schedule. It automatically prevents you from planning too many assembly operations in parallel, respecting your actual workforce constraints. The result is a feasible schedule that matches your available skilled operators. Once the schedule is generated, we use the plots tool to verify how our secondary resources are being used. This shows us the utilization over time. In this example, we've set a maximum of 3 assembly operators available at the same time. That number is configurable, just adjust it in the calendar settings. The plots tool also highlights which specific operations are using a particular skill at any point in time, so you can quickly identify them. It's straightforward. Define the skills needed for each operation. Set the number of available operators in your calendars. And Opcenter APS handles the scheduling constraints automatically. But you can also use the tool to determine how many operators you would need to produce as fast as possible. To do this, we go to the Sequence menu and activate the Disable Secondary Constraints option. This allows us to schedule without limiting the number of operators defined in your calendar. Once we run the plan, we open the Plots tool to visualize resource utilization. What we see is interesting. Most of the time, your 3 assembly operators are sufficient to handle the workload. However, there are specific moments, shown here in red, where you would need additional operators to maintain that optimal schedule. This gives you clear visibility into your resource gaps and helps you make informed decisions about staffing and capacity planning. Second, identifying bottlenecks and testing capacity improvements. Every manufacturing facility has constraints. The challenge is identifying which machines are limiting your output, and then deciding if it's worth investing in more capacity. We're looking at our previous forward by due date schedule, and this time we'll use the utilization window tool. It breaks down each machine's time by usage type: production, idle time, downtime, or setup. Look at the pin insertion machine. It's running continuously whenever it's open. That's a clear indicator. This is your bottleneck. Now, let's see what happens if we increase its capacity. First, we check the current schedule performance using the Statistics tool. Here we can see that with the current setup, 43 orders are late, with a total of 117 days of delay. To simulate capacity improvement, we add a second pin insertion machine to the workshop. All we do is open its production calendar and activate it. Now we reschedule and check the results. With the additional capacity, we now have only 16 late orders with a cumulative delay of 87 days. That's a significant improvement. Opcenter APS won't make the investment decision for you. Only you can decide if these numbers justify buying a new machine. But what it does is let you run these simulations quickly, so you spend less time gathering data and more time making strategic decisions. Third, optimizing machine utilization by reducing setup times. You want your machines producing, not sitting idle during changeovers. The question is, how do you sequence jobs to minimize the time spent setting up between orders? The answer starts with defining attributes that characterize your orders and products. Let's look at some examples. This isn't exhaustive, but it shows how flexible Opcenter APS is. First attribute, customer type. You might designate orders as either civil or military. This ensures that military and civil products never get mixed on the same production run. It's a simple rule, but it has big implications for scheduling. Second attribute, product size. Not every machine can produce every size. So we define which machines can handle which sizes in a capability matrix. Opcenter APS then automatically respects these constraints. Now, here's where setup times come in. We can define setup times automatically based on these attributes. For example, switching from a civil order to a military order might require a fixed 2-hour changeover. Or we can build a matrix, different setup times depending on which size change you're making. Let's see this in action in the sequencer. We start with our forward by due date schedule. The statistics show 16 late orders, 87 cumulative days of delay, and 6 days of setup time. Now we try a different approach. Instead of prioritizing due dates, we reschedule using an APS rule that minimizes overall setup time. The results are interesting, and they show a trade-off. Yes, we now have more late orders, 21 instead of 16. And our cumulative delay goes up to 95 days. But look at the setup time. It drops to just 19 hours. We've significantly reduced idle time on the machines. Opcenter APS won't decide which version is better for you. What it does is let you run both scenarios quickly so you can see the impact of each strategy. Then you can make an informed decision about what matters more, meeting due dates or keeping machines running. Fourth, scheduling maintenance orders alongside customer orders on the same machines. In defense manufacturing, maintenance can't be ignored. Equipment needs to be serviced on a schedule, and those maintenance orders compete for machine time with your production orders. The challenge is keeping both on track. Here's one way to handle it. First, we filter the schedule to select only MRO orders, that's maintenance, repair, and operations. We apply a backward by due date rule to position these maintenance orders as late as possible without missing their deadlines. This creates a foundation. The maintenance orders are locked in place, protecting the equipment schedule. Now we have the second pass. We schedule all the remaining customer and production orders using forward by due date to fill the available slots. The result is a balanced schedule where maintenance gets done on time, and production orders fit around it. You can review the statistics to see how well both priorities are being met. You could also choose to apply a different scheduling rule to your customer orders. For example, here we'll select the APS minimize overall setup rule to reduce setup times for production orders. What does this mean? It means you can prioritize due dates for your MRO operations while optimizing resource efficiency for customer orders. And that's the flexibility that Opcenter APS gives you. The ability to quickly customize your scheduling rules exactly the way you need them. And here's the key insight. The rules you use today don't have to be the same rules you use tomorrow. What's optimal for today's schedule might not be optimal next week. Market conditions change, supply chains shift, equipment needs evolve. Opcenter APS gives you the flexibility to adapt. You have many scheduling rules to choose from, multiple parameters to adjust, and endless options to customize the schedule to your exact needs. You can experiment, test different approaches, and change strategy whenever the business requires it. That's what makes Opcenter APS powerful in today's manufacturing environment. It's built for change, not rigidity.